starting? Yeah, so long day. Good evening everyone. I am Neela and I work with CD Adapco, which is a Siemens business. So today I will be talking about our battery modeling technology, our portfolio of products, how it is relevant to this conference. Later you can ask me any questions you have. So today's agenda would be I'll give a very brief corporate introduction of what my company is and what we do, and our cell design tool, and what is a MSc or a microstructure electrochemistry tool what we have. Later I'll show you how we can use our flagship product for a module analysis or a pack analysis of batteries, and how you can integrate within an overall system design. I'll talk about what overall system design, what I mean by overall system design is. Later we'll conclude it, and after the presentation I have a couple of very quick demos using only the cell design tool. I am not going to give a demo on all the modules, just the first or the primitive module is what I'm going to show today. So CD Adapco is a part of Siemens business. It's a 35-year-old technology. Our flagship product is Star CCM Plus. So we are a CFD company originally. CFD is computational fluid dynamics. I'm not sure how many of you are very aware of what CFD is and what we do. So let me give a very quick introduction. CFD, as I said, stands for computational fluid dynamics. So we try to use our basic Navier-Stokes equations of fluid mechanics and try to analyze the flow. Along we can include complexities such as reactions, electrochemistry, electromagnetism. So it will be a multi-physics tool. Apart from Star CCM Plus, which is predominantly used in vehicle industry or automobile industry, as CFD is first adopted by those industries. Later it has slowly crept into markets of oil and gas, chemical processing industries, and we will see how it can be used for a battery thermal management. So apart from Star CCM Plus, we have a portfolio of other products such as Battery Design Studio, which I will be talking about today. HEATS is our optimization tool. DARS stands for Digital Analysis of Reaction Systems, which I primarily work on, and a couple of other products for casting and all. So the industries which we cater to are fluid, any flow. Take let's say I support clients like Shell, Samsung for battery thermal management, Renault for battery single cell analysis, Shell for annular flows. So different industries can be, Star CCM Plus can be used in many different industries. So here is a list of different industries we cater. Ground transportation, it's our bread and butter. Apart from ground transportation, we have oil and gas, life sciences or pharma, electronics, marine, CP or chemical processes, and power generation. So this is what I will be talking about today. There is a new aspect of CFD which comes into picture apart from the electronics or electrochemistry. So I tried to keep it very simple because many of you would be new to CFD. Let me know whenever you have a question. Our cell design tool is a 1D tool. It's a simple electrochemistry tool. So what we have there, we will see what it is in detail. So we have a set of models through which you can understand the electrochemistry, the performance of a single cell, and a lumped heat or a thermal analysis. By lumped, we'll see what I mean. Apart from that, so that is a separate tool which is called Battery Design Studio. So the rest three chapters are integrated to Star CCM Plus. Star CCM Plus is our CFD product. Microstructure electrochemistry, we try to model batteries in a CFD framework. We will see what they are in detail. We'll try to construct electrodes from a bottom-up approach. So you try to place particles of an electrode and where you can actually go and adjust the porosity, tortuosity of that particular electrode. So that is what we call a microstructure electrochemistry, and it is embedded within our CFD product or Star CCM Plus. Later we move to a module or a pack analysis. So in pack I have several batteries together along with a coolant flow. So what is of my interest, let's say companies like Samsung and all are very interested in a battery thermal management study. Let's say one cell in my entire battery pack is just shooting, the temperature is shooting up. I will have to replace the entire battery pack at some stage. I will talk about it in detail. So we will study the spatial effects of each and every cell as well as the coolant flow around it. Coming to overall system design, I just take this battery pack and put it in a vehicle and see. And I want to simulate the entire vehicle along with its movement. So that will be the highest level of complexity I can model. We have a facility where you can couple CCM Plus or Battery Design Studio with external codes such as MATLAB or AMI where you can write your own user code for the higher complex study. So I will be covering all of these very crisply in my presentation. You can always email me or come back to me if you have any more questions. So first I'll be starting with a cell design tool which is called Battery Design Studio. So I come from a CFD background. So I work on multi-phase flows which are used in oil and gas and chemical industries, and my intervention comes here and here. So I get this the cell design file from one of my colleagues who works on electrochemistry, and I get this file. I try to create a pack out of it, and I run a thermal simulation to see how the CFD solvers talk to the electrochemistry solvers, and we'll see how they work. And I will give him back a thermal profile for each and every cell in the battery pack. So this is just an overview of what I'll be covering for BDS or Battery Design Studio. I will show what a TBM file is. TBM file is just an output of Battery Design Studio. I'll quickly show what are the different models and which are based on literature, and I will show how electrolyte properties are taken care in the software. Later we'll see what is the technique we implemented for aging study. Battery Design Studio, you can build these three shapes. So it is a preloaded software. By preloaded, what I mean is you have all the materials which are generally used in lithium-ion industry already loaded along with their properties, and you have a set of cells which are already available, be it stacked, prismatic or cylindrical, already available in the software. So you can always go back and change the numbers or the geometry of that particular cell or the material properties of a particular material. You can always add new materials also. So performance prediction, we have one detailed electrochemistry model and a couple of equivalent circuit models. I hope you're all aware of equivalent circuit models. Anyway, I'll just cover them a little more in detail. So TBM file is just an output of Battery Design Studio. So whenever you create a file or a new project in Battery Design Studio, it saves it with an extension of .tbm. That's what I mean by TBM files. Now, whenever you create a project in Battery Design Studio, what all inputs are required from your side? The geometry has to come from your side. What is the chemistry? What are the different materials involved has to come from your side. So once you provide this, you can run a simulation, a 1D simulation in Battery Design Studio. What it will give you is it will give you all the electrochemistry properties along with a lump parameter for temperature. It will not give you a distribution of temperature along the cell, but it will only give you an average or a lump value of temperature. So a preliminary thermal analysis can be performed. Now, how do we use this TBM file?
Excuse me. You written a bill of materials also we can feed into that.
Yes.
Let's
say you have material, you can enter these many rupees or dollars per kilogram of it. It will give you a very preliminary estimate of the bill for that particular battery. Let's say you are entering electrode or electrolyte, any even a binder, you can input its cost, a certain dollars per kilogram or certain dollars per pound. So it will give you a rude estimate of the cost. Yes, so coming to Battery Design Studio, as I said, it is a tool for material developers and cell designers. Let's say you want to change the material properties of a particular material, or vary the concentrations, or add an additional additive or a binder and see how it is affecting the performance. You can do that using Battery Design Studio. Now, once this TBM file is created, you have to create a pack out of which generally I do. So what I get the TBM file, I import it into StarCCM+, which is our CFD program. Once I import it, I have an automated script called battery simulation module, which I will use to create the pack analysis. Once I turn the battery simulation module on in StarCCM+, it will activate all the electrical solvers required for this kind of simulation. Later, it will solve the problem using a CFD framework. So let me give a very brief overview of how CFD works. So you have a geometry which we call a CAD. That particular geometry you try to discretize into many elements, which is called mesh. Later in that, using that mesh, we solve our Navier-Stokes equations, energy equations, including the solids equations at each and every point of that mesh. So that is how we get a solution of CFD. So in StarCCM+, for thermal analysis, you have to solve it using a CFD framework. So that's what I do. I take the TBM file, I arrange the battery module pack. I will get the configuration, let's say, from my client. I arrange them in series or parallel, and later I run a heat transfer analysis or a CFD analysis to see what is the distribution of temperatures. So I have a couple of slides showing the BDS GUI. So as I said, there is a default value for all the parameters available for different geometries and for different material properties as well. If you want to change anything, you're welcome. If you're looking at, if you're a cell designer, if you want to play with the geometrical parameters, you're most welcome. You can go and do it. So these are different snapshots which I have for geometry in BDS. Coming to database, as I said, many industrially used materials are already available in the database of BDS. So you can just go there, go down and select those, let's say you want to add a binder or a new salt or a solvent. You can just add them from the available database. But let's say you're testing a new material and you want to add it to the database, you can do that. You want to vary any particular property of an already existing material, you can do that. So you can, once you create the cell, you give a load file. By load file, what I mean is, let's say You want that particular cell, you want it to run at a 1C rate for this time at this particular temperature. So you have to provide those load files, and once you provide them and you run them, you have the results available in generally a graphical format. So you can always discretize them and use the data later. So coming to the models implemented, we have two equivalent circuit models and one detailed electrochemistry model. So they are based on these particular literature available. You can come back to me and ask for literature. You can yourself go and search for them. So the two models, empirical models or equivalent circuit models available are MTG and RCR. Both of them are for EV or HEV kind of analysis. Let's say you do not have all the properties of that particular cell, which is generally the case unless it is a cell manufacturer. So few of our clients are manufacturers, and few like Mahindra, they just get the batteries from somewhere else. They do not have any idea about properties of the cells. They only have some test data which the supplier provides, which is generally the case in battery industry. So if you have only a test data and if you want to run some kind of analysis based on that, you use equivalent circuit models. So you try to fit that particular battery using some circuits. It will be a regression problem. So you try to identify a set of parameters like time constants or resistances for a circuit. You try to mimic the battery or a cell as a circuit. So coming to the distributed model, as you see, it is the complexity increases as you move from empirical models to a detailed model, because detailed model actually solves for all your equations. So the distributed models, these are the yes, our NT is a Neumann, this is scientist name, so you can just go and yes. So in RCR you can go and add n number of circuits. So as you increase the number of circuits, more accurate your. No, not to, because I still have a lot to cover. You can drop me an email, I can respond. Yeah. So the models, these are the different equations it will solve for. Probably you are a better judge of what the equations are. I do not primarily work with these. So you can have temperature dependent and concentration dependent solid phase diffusion coefficients, which you can provide into the software. The kinetic expressions are Butler-Volmer and Tafel. Tortuosities can be specified for you, which is generally not very readily available in many other codes. So that is something which we think is important. Yes, so this slide might not be very relevant for you, but for corporates, they generally like to know which data is readily available or in the literature and which has to be obtained only from suppliers. So we just try to segregate the data that way. Some validation results of Battery Design Studio. Here we have simulation versus test results, and this is the error which is blown up and plotted. You can come back to me if you want these validation papers or any published material shared. I'll share them with you. So this is again for different C rates. We try to match with experimental or lab data. So we observed that the error is within 6.5% of total discharge. Again, this is published material by us. Yes, so coming to another application where we tried comparing the results with 3 different temperatures and 3 different rates. Here we have green, red and blue are 0, 15 and 30, and different rates are specified there. So this is again a comparison of lab versus our data or BDS data. Few more. Yes, so coming to RCR model, as I talked about it previously, it is a regression based model. So you can add as many circuits as you want. So number of circuits you have to, it increases the number of parameters you have to regress. And there are a few regression models already available in Battery Design Studio. So you try to get the data from a supplier or from your lab, and you try to regress that particular say a 2 RC circuit for that particular data. So you have to find all the different parameters involved. So this is one application for a HEV battery for a pulse test, which is generally asked for. So capacity fade, again, how is it modeled using RCR model? We have the resistance plotted for different time after 4 weeks, after 6 weeks, along with the experimental data here. Yeah, a quick comparison of the times. Of course, it's an apple to orange comparison because RCR is just an empirical model, and distributed model actually solves for all your equations. So you have a 46, almost a 10 power 4 times difference between an RCR and a distributed model. However, these times are nothing when you actually look at the CFD simulation. So CFD simulation always depends upon your mesh and your mesh size, but an hour or two does not really probably matter if you're actually looking for a CFD simulation of the entire battery pack. So electrolyte models are again taken from literature. So these are some published results where how electrolyte properties are taken care of with changing concentrations at different temperatures. Just put them and put it here. Yes, so aging, we account for an SEI growth aging. Do not ask me how SEI grows, I do not know. So we implemented a model by Fleet, which is available in literature by Fleet. So that is the model implemented, and it requires a few parameters from you. I can share that literature with you if you are interested. Yes, so these are some values what we have, how the thickness increases after a certain time for different temperatures again. So you have a higher temperature of 60, 30 and 50. So how does the thickness increase with time, and how does the corresponding resistance increase with time? So I have some plots comparing initial versus an aged cell performance. Yes, so I hope you got, it's a very brief simulation, a very brief presentation on capabilities of Battery Design Studio. So it's a 1D tool where you get the electrochemical properties of the cell, and if you're running a charge discharge cycle, you get them from the cell once you give from the software once you give the load accordingly, and you get a lump temperature value. So the temperature or heat release is averaged throughout the cell, which is resolved in detail when you move to a modular attack analysis, when you couple it with star CCF+. So now I have just a couple of slides on microstructure electrochemistry, because It is a complex CFD simulation. So we have something called a discrete element model implemented, which is generally used for particulate flows or particular analysis. So we use that model in star cesium plus to actually create our electrons based on if you already have the details based on a SEM image, you can actually go and place electrode particles of different sizes and you run an analysis of it. So if you are designing an electrode, it makes so much more sense for you to look at this model because it will be a computationally expensive model. Typically in CFD, the length scales which we look at, let me tell you, my client is Shell, so we look at pipelines of 100 meters and we try to analyze annular flows in such kind of length scales. So typically CFD is generally for a higher length scale problem. So when you move to this kind of length scale, you have to refine your mesh. So okay, let me put it this way. The problem will be computationally very expensive. You need much higher computing power or cores, and you need much more time to run such kind of simulations. So any CFD problem, you have to judge how deep you want to go. Do you really want to go and solve the micro scales, or are you just well off with 10 power minus 3 meter scale? So in this particular problem, you have to. So you have to use it if you're working at a material at a micro level. Yeah.
Now the battery design is pretty complicated. Whether it is a real-time system, that means I connect one cell to a system and can I do charge discharge, can I power, can I make harmony, what is the C rate, can I capital log, charge capacity or capital log, can we do like that? Connecting a cell to a PC. And
Connecting a cell to a PC, no.
no, means we can have a tag cards and connected to the PC. Like
I don't
lab
think
view, just
so.
like
No.
lab view.
No, it's a completely standalone tool where you have to provide all the parameters of that particular cell and give a load or a program file.
Then how it is different from MATLAB Simulink? That Simulink also
I personally have not used MATLAB, but I know for this particular application. But there's a lot of user coding involved in MATLAB.